Look closely at this pygmy three-toed sloth. It is one of a handful of species currently teetering on the absolute edge of existence, with populations dropping to the double digits, or even single digits. These animals are quite literally the last of their kind. When a species is pushed this close to the brink, the traditional narrative usually involves a single, obvious villain, a poacher with a rifle, or a bulldozer clearing an old-growth forest. That straightforward cause and effect rarely fits the modern reality. Today, animals are caught in ecological butterfly effects. A specific demand on one side of the world can quietly seal the fate of an animal thousands of miles away. These isolated populations are victims of invisible, interconnected global chain reactions that humans have unknowingly set in motion. In Mexico's Gulf of California, the vaquita porpoise is down to a population of perhaps 10 individuals. Yet, the fishermen casting nets in these waters are searching for something else entirely. This is a dried swim bladder from a totoaba, a large fish that shares the vaquita's habitat. In parts of Asia, these organs sell for up to $10,000 per kilogram on the black market, prized as a delicacy. That massive price tag has drawn international organized crime into the Gulf. Cartels now finance illegal operations that blanket the water with gill nets to meet the global demand for totoaba. This map shows the vaquita's shrinking territory and the designated zero-tolerance area meant to protect it. Because vaquitas are roughly the same size as the totoaba, they get caught in the cartel's heavy mesh nets and drown, collateral damage in a high-stakes illegal trade. The population data reflects the impact of these nets. Over a recent 8-year period, the vaquita population crashed by 98.6%. In the peat swamps of Indonesia, the Sumatran tiger is facing a biological disruption that began with the landscape itself. Nearly 20% of Sumatran tiger habitat was cleared for industrial palm oil and acacia between 2000 and 2012. This fragmentation isolated tiger populations into disconnected pockets of forest. That isolation made the tigers vulnerable to a biological wildcard. In 2018, African swine fever began sweeping across Asia. The virus does not infect tigers, but it killed off 80 to 95% of wild boars, the tiger's primary food source. With the collapse of their prey base, starvation has forced nursing tiger mothers to abandon the forest interior in a desperate search for calories. This displacement drives tigers into rural villages, where human-wildlife conflicts have tripled. Many are killed in wire snares set by local farmers to protect their livestock. A different biological disruption is occurring on the island of Java, inside Ujung Kulon National Park. The Javan rhino already lives in the shadow of the active Anak Krakatau volcano. A single tsunami or eruption could devastate the entire population. But an invasive plant is causing a more immediate crisis. The arenga palm is spreading across 60% of the park, forming a dense canopy that chokes out the native woody plants the rhinos eat. Whether it is a virus erasing a predator's prey or an invasive plant starving a giant herbivore, these disruptions in the food web act as an invisible wall against species recovery. In the Russian Far East, the Amur leopard faces a threat that is microscopic and genetically rooted. With roughly 100 individuals left, extreme inbreeding has compromised the species' natural immune systems, making them highly susceptible to disease. Encroaching infrastructure and logging have forced these leopards into smaller territories, where they frequently come into contact with domestic dogs and wild foxes. These contact zones have introduced canine distemper virus to the population. The virus attacks the respiratory and neurological systems, and for a species with such little genetic diversity, a single outbreak could be catastrophic. Habitat loss has transformed the landscape into a series of infectious contact zones, forcing fragile genetics into direct proximity with disease. To prevent the extinction of these species, conservationists are shifting their focus toward the specific mechanisms of these cascades. In Mexico, they deploy 3-ton concrete blocks armed with metal hooks. These are dropped into the ocean to physically snag and destroy the illegal gillnuts. Elsewhere, the interventions are equally aggressive. In Java, workers are clearing 10,000 hectares of invasive palm by hand, while in Russia, veterinarians are building health databases to select the most disease-resistant leopards for breeding. Simply establishing a protected area on a map is no longer enough to guarantee survival when the primary threats are viruses, invasive plants, and global black markets. Nature is an infinitely interconnected web. Saving these final survivors requires us to intentionally unspool the deadly chain reactions we have started, healing the entire ecosystem before the echoes fade.